Hello everyone, welcome to our channel Spy IIT Guwahati. Today we are going to discuss the solutions of the problems, optics through problems, and finally we will also announce the winners of this event. So first we will enter the email address, full name, school name and class. Next the first problem. In this problem we are given some information about hypermetropia and what happens to the image if a person is having hypermetropia. You can see the image forms beyond retina. So we want this image to be at the retina. That means we want this beam to further converge to the retina point. So for that we need converging lens, that means convex lens. So finally if we use convex lens, the image will be forming at retina. Next is the person is having myopia. In myopia case, the image forms within the eyeball. That means we want this image point to be at retina. That means we want to diverge this point. For that we need diverging lens, that means concave lens. So if we use concave lens, the image will be forming like this. Next is the person cannot see the object closer than 25 centimeter. It's perfectly normal because human eye can see up to 25 centimeter. Next, in this puzzle there are 11 oftenly used optics terms. We just need to give some time to find them. So if you see carefully, you'll find that refraction, concave, eye, mirror, ray and focuses are correct, while convex, reflection and lens is incorrect. Reflection, lens, convex incorrect, while refraction is correct, eye is correct, focus is correct, mirror is correct, concave is correct, ray is correct, and microscope is not there. Next, in this problem we need to find the incorrect statement about mirror. The first option is we do not need the size of plane mirror to be of our size to completely see from top to toe. It's perfectly correct because if we have a size of mirror half the size of our body, we can completely see our body. Next is angle of incidence is equal to angle of reflection. Even for curved mirrors, yes, this is correct because this is the law of reflection. Third option is convex mirrors are used in vehicles as rear view mirror because of their wider field of view, which is also correct. The fourth option is image formed by concave mirror is always real, which is not correct because if you see the image formation, if the object in this F figure, if the object is in between focus and pole, the image form is virtual. So the incorrect statement is this one. Next, to find the location of the bulb in front of concave mirror. So the principle here is if we put the bulb at the focus, the ray of light will be parallel, which will go longer distance. So we will be putting the bulb at the focus. Next, to find information about image if the object is placed between F and O in front of convex lens. So if you put the object in between F and O, you can see in last figure it will be virtual on the same side in between infinity and object. Yes, infinity and object, this is correct. Image will form on the same side, yes, it is correct. Virtual and endless, correct. That means all of the above are correct. Next are these. To find the size, compare the size. When the object is located at infinity, image will be at focus, which will be highly diminished. When between infinity and C, it will be between focus and C, it will be again diminished. Object at C means image will be at C, same size. Object in between C and F means image will be in between C and infinity, enlarged. At F means image will be highly enlarged at infinity. Object in between F and O means image will be in between infinity and object, again virtual enlarged. Next, the concave lens. This is the concave lens, which is basically thin at the middle and thick at the edge. Image formed due to concave lens is always virtual and diminished, correct. Concave lens is diverging in nature, correct. Next, this is basically numerical type of problems. Here refractive index is given as 1/2, so the velocity will be c by 1/2, that is 2c, which will be 6 lakhs km per second. Next is a 10 cm long stick is kept in front of a concave mirror having focal length of 10 cm in such a way that the end of the stick closest to the pole is at a distance of 20 cm. What will be the length of the image of the stick? So let us make the diagram of this problem. So it will be like this. Basically the stick is AB. B is at center of curvature, so the image will be again at C, which will be B prime, and the object A is in between infinity and C, so the image of A prime, will be in between C and F. So clearly you can see A prime B prime is less than AB. That's why the image will be shorter than the actual stick. Now to fire using a magnifying glass, so we will be basically needing convex lens, and as it is given that you need always keep distance from fire, so higher the focal length better. So we will be using convex lens with 5 cm focal length. Next is to find focal length from power. Power is negative, means it is diverging, while power is positive, means it is converging. So diverging means it should be a concave lens, and if you convert it using this formula, it is basically 1 meter, which is 100 centimeter. Next is again an object of height 2 centimeter is placed 20 centimeter away from a convex lens of focal length 10 centimeter. Another convex lens of same focal length is placed 40 centimeter away from the first convex lens on the opposite side of the object. What will be the height of the image? If you again draw the figure, you can see there are two lenses. The object is placed at the center of curvature from the left lens, so the image will be again center of curvature, which is again the center of curvature of the second lens. So the image, because of this second lens, will be again also at center of curvature, and as these are at center of curvature, both the image size and object size will be same. So answer is 2 centimeter. Next, there are some general quiz problem. First is, what invention did Alfred Nobel make his fortune? He invented dynamite. Albert Einstein was given Nobel Prize in 1921 for photoelectric effect. This black hole image was first published in 2019, which is quite recent. Abdul Kalam was honored with Bharat Ratna in 1997. Gravitational wave signal was detected on 14th of September 2015. That is why it is named as CW150914, and that's it. So finally, we would like to inform you that there are 118 responses from various classes. As this event is mainly for the class 10 to 12 students, we basically want to give the cash prize to these students only. If you see the mark distribution also, there are people who scored 49, which is quite impressive. The average is 33.38. We have already distributed the certificate who have secured 40% marks successfully, and here is the list of winners: Rupender Singh, Jashanpreet Kaur, Tasmeen Sultana Majumdar, Akash Ratan, Monushree Dutta, Tarang Kumar Singh, Adrija Das, Kaustav B. Arya, Riya Chamiyal, Ramandeep Kaur, Prantik Nath, Lokesh Mehra, Aditya Goswami. So we would like to inform you that we will be sending you a mail for further processing of your prizes. I hope you like this video, and we'll see you soon. Thank you.